All right, folks, welcome back again. Apologies for talking too long here. Some of these things, to do them justice, you have to go a little bit longer than I'd like to. So that's what we're going to do. And I'll do this as quickly as I can so as not to take too much of your time. So, a summation notation, it's a new notation. This big E looking thing is called a sigma. And so when we say the summation from 1 to n of a sub I, that means you take a sub 1, a sub 2, a sub 3, all the way up to a sub n, and you add those numbers together. So we're going to use this summation notation in order to evaluate, and we're going to just keep it fairly simple with what we're doing today. So when I see number 11, it says the summation from I equals 1 to 5 of 3I. What that means is basically we're plugging in 1, 2, 3, 4, and 5 for I and adding all those results together. It would look something like this: 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. And some of you can do all that multiplication in your heads, and you could probably just write 3 and 6 and 9, etc. But when we add all those together, we get 45, regardless of if we show our work or not, hopefully. All right, let's take a look at number 12. You'll notice this time it actually starts at 3. It says from I equals 3 to 5 of I squared minus 2. So our first term is going to be 3 squared minus 2, so that would be 7. If I'm skipping too many steps for you, come talk to me about it in class. I'll help you understand what I'm doing here. Then we go to 4. That's 4 squared minus 2, so 16 minus 2 would be 14. And then finally 5. 5 squared is 25 minus 2, so we would add 23. 23 plus 7 plus 14, and I don't know why I switched the order all around on you guys, but there it is. It's 44. All right, one more. This time is the summation from I equals 0 to 8. This could be fun, and by fun, I don't know why I'm saying the word fun, because this is not fun. But here we go: 1 over 0 factorial plus 1 over 1 factorial. And I'm just going to do a dot, dot, dot and say plus 1 over 8 factorial. Now, watch what happens when we start doing this. It's kind of an interesting little problem. What we get is we get 1 over 1 plus 1 over 1. 1 over 2 factorial is 1/2. 1 over 3 factorial would be 1/6. And I'm going to keep going. As a matter of fact, if you want to pause the video, I'm going to skip ahead where all the solutions are written down. All right, so here we go. I've added all these fractions together. I've used my trusty calculator to get a nice approximation. And this is actually a really interesting one. You might recognize this number if you're really thinking: 2.718, and I believe that keeps going to 8. And you might know that this number, we've seen it before. It's E, your favorite letter number, unless you're into pi. All right, so let's take a look. We got a couple more left here. So an infinite sequence is called a series. And you might think, how do you find the sum of an infinite sequence? That could be kind of tough because they're infinitely big. However, sometimes the sequences get smaller and smaller as you move forward. So we have ways of actually tallying those or finding totals. And as we move ahead, we'll do some formulas. For now, we're going to do some basic stuff. Now here it says find the third partial sum. That's really important for us to know. That's another way of saying the sum of the first 3 terms. So if you see something that says the fifth partial sum, that would mean the first 5 terms. And in this case, though, we're doing 3. So here we go. We're going to evaluate the first 3. When I plug in 0, I've got 1/10 to the 0. Then 1 would be 1/10 to the first. And then 1/10 to the second. This is 1 plus 1/10 plus 1/100th, which is 1.11. Now some of you may realize, hey, this pattern would continue. If I kept going, I'd continue to add ones. So the third partial sum is exactly 1.11. But if you wanted to keep going, you could actually find an infinite sum, and I bet some of you would recognize that this is 1 1/9. All right, our last slide. words you never thought you'd hear on this video. We're going to work the opposite way. We're going to use sigma notation to write the sum that you see here. Now here's what I'm going to start with. I'm going to say the summation from I equals. Now let's look at what's going on this pattern. I see in the numerator it's always 2, so if I want to I could go over here and just write a 2. I don't have to really spend any time thinking about that too much. Let's write the 2. My next question I always ask myself though is how many terms do I see? Well, it starts at 1 and it goes to 12, so I know I'm going from 1 to 12 here. And then the pattern, we always add 1 plus some ever increasing number in the denominator, so we're just going to call that 1 plus I. Beautiful. Also not too complex, something you can definitely handle. All right, number 16, slightly more challenging. Why don't you do this? Pause the video, take a minute, try to do this one on your own. All right, welcome back. I'm going to go ahead and walk you through this one. I know some of you probably didn't pause the video, but I'm hoping you did. I hope you did. Those experiences are good for you. So we're going to go from I equals 1, 2, 3, 4, 5, from 1 to 5. Now I'm going to treat the numerator and denominators separately. And what I notice is in the numerator, it's always powers of 3. 3 to the first, second, third, fourth, etc. 3 to the I power is what I'll call it. And you know, when I look at this problem, I don't like that I as an exponent, and so I'm going to make an executive decision and decide that this one is K instead, and you are empowered to do the same should you choose. Okay, now if you notice the pattern in the denominator, you may not be used to seeing numbers like 1, 2, 6, 24, and 120, but the more you work with factorials, the more used to these numbers you'll get. So what this is 1 factorial, 2 factorial, then it starts getting trickier, but times 3, then times 4, then times 5. So what we have here is K factorial. All right, so look out for that pattern, that sequence 1, 2, 6, 24, 120. The next one after that would be 720, and you could keep going from there if you'd like, but I wouldn't like to do that because I would like to end this video today. And there it is. So folks, you have a spectacular day. Come to class ready to work. Again, apologies for going a little long here. I hope that it helped you to learn this well, though. We'll see you soon.